Hello everyone. In the last video, we developed a Spring backend and used access and refresh tokens for authentication. We implemented our own token generation and verification. In this video, we will go through how to leverage Spring's OAuth 2 resource server and its built-in classes to handle token verification and generation. You'll see usage of the new Spring security filter chain, as well as using public and private keys for signing and verifying tokens. We start off at the Spring Initializer website to create our Spring project. We'll add the MongoDB, OAuth 2 resource server, Spring Web, and Lombok dependencies. When ready, hit generate and a zip file will be downloaded. Extract it and open it in IntelliJ. We'll start with our security configuration, create a security package and a web security class. Add the configuration annotation, enable global method security annotation with pre-post enabled and SLF4J annotation if you want to use a logger in this class. Now we define a security filter chain bean. We configure the /API/auth endpoints to be publicly accessible, while every other endpoint must be accessed by authenticated clients. We disable CSRF, CORS, and Spring's HTTP basic login and registration. Then we configure the OAuth 2 resource server. We specify to use JWT authentication, and we customize it to use a converter that will convert the JWT token class to our own user class. This will make it easier to use or retrieve the authenticated user from Spring's security context. We'll create the actual converter class in a moment. Lastly, set the session policy to be stateless and configure the exception handling with the bearer token entry point and access denied handler, which all come from the OAuth 2 resource server. Before we can create the JWT authentication converter, we need to have a user class. Let's create that next. Create a document package and a user class. Add the document, data, required args constructor, and no args constructor annotations, and implement the user details interface. Next, we define the ID, username, and password fields. Note the username and password variables are marked with non-null, which means the required args constructor will have these two variables as arguments. Lastly, implement the required methods from the user details interface and return the correct values for each method. While we're in this area, we'll also add the user repo to enable user lookups, create the repository package and the user repository interface. Extend the Mongo repository of type user and string. Define two methods to return an optional user by username and another to return a boolean whether a user exists by a given username. Now we create the JWT token to user converter class. In the security package, create a JWT to user converter class. Add the component annotation and implement the converter interface of type JWT and the username password authentication token. Make sure the converter import is from the Spring Framework package. And then implement the convert method. Here we get the decoder JWT token. This will be the access or the refresh token, as we'll use the same converter for converting both tokens. You can also use separate converters if you wish. The user ID is in the token subject, so we'll create an empty user class and set the ID coming from the token. Then we wrap the user and the JWT token in a username password authentication token. So whenever you retrieve the authentication object from Spring Security Context and you call the .getPrincipal method on it, it will return the user object. And when you call the .getCredential method on it, it will return the JWT token. Note, this is a bare bones user object with just an ID, which is essentially what JWT is, a stateless object where we avoid database calls. But if you want the full user object here, you'll have to make a database call to retrieve and set the full user object. Coming back to our web security class, we inject the converter and configure OAuth 2 resource server to use it. Now, before the resource server can verify tokens or issue them, it needs to know what public and private keys to use. What we'll do is read the public and private keys supplied from files. So let's create a key utils class in the security package. Add the component annotation. The idea here is that the application will be supplied with file paths to the public and private keys, and then it will read them in and create the necessary classes for token verification and issuing of tokens. I'll define two variables which get their value from environment variables for the public and private keys used for access tokens. While we're here, I'll also create the same variables for the refresh token. Next, I create a private key pair for the access and refresh tokens. This will allow us to read from a file once and then store it in a variable. Then create 4 public methods to retrieve the public and private keys, which are empty for now. Next, we create the getAccessToken keyPair method. Here, we check if the access token keyPair variable is null. If it is, we use the getKeyPair method to read the keys from the specified file paths. We'll create this method in a moment. And finally, return the access token keyPair. We do the same for getting the refresh token keyPair. Now we can finish our public methods. Return getAccessToken keyPair.getPublic, and we need to cast it to an RSA public key. For the getAccessToken private key method, call the .getPrivate method on the key pair and cast it to an RSA private key, and do the same for the refresh token methods. Next, let's define the getKeyPair method, which will take a public key path and a private key path as arguments. Define a key pair which will be populated later and returned. Then create a public key file and private key file from the file paths. Next, we need to check if the public and private key files exist, and if not, we'll throw an exception. If the files exist, we create an RSA key factory. Then we read the bytes from the file. Then create an X509 encoded key spec using the bytes we read in. And then use the factory to create the public key from the public key spec. Next, I'll copy paste the 3 lines to read the private key from file. We need to change the private key spec to be a PKCS8 encoded key spec. And call the generate private method on the key factory. Then create a key pair from the public and private key and assign to the key pair variable. Also ensure the private key variable is a private key class and return the key pair. Next, we'll wrap all the file reading code in a try catch block and we'll tell IntelliJ to add the catch clauses. Then we'll collapse the catch blocks. Now we need to define the environment variables. I will rename application.properties to application.yml. Open the file and define the access token private and public variables. The value of these properties will be passed in through environment variables, so we use the $sign curly braces syntax. We'll do the same for the refresh token public and private key paths. Next, I'll create an application-dev.yml file to be used when the dev Spring profile is active, and I'll define the environment variables here, which in production would have been passed in at runtime. In development mode, we'll use public and private key files from our root folder. We'll have a access refresh token keys folder, and inside we'll have the public and private key files. You can generate the public and private keys on the command line using SSH keygen, but I'll show you how to do it in Java to make it easier for development. So what we'll do is when we detect that the public and private key files don't exist, we will generate them. In production, we don't want to do that. We want to control the keys used by the app, and when the app is scaled to multiple instances, you want each instance to use the same set of keys. Otherwise, tokens issued by one instance are not valid in another instance because it uses a different set of keys. So coming back to our keyUtils class, we inject the environment variable. And in the else block, we're going to check which profile is active. If it's the production profile, then we throw the exception. Below the if-else block, we're going to generate our public and private keys. We define the directory file instance, then we check if the directory exists, and if not, then we create a directory. Then we create an RSA key pair generator. We initialize it with a key size of 2048, and we call generate key pair on the generator and assign the result to the key pair variable. At this point we have our public and private keys, but only in memory. Next we want to write them to files so we can reuse the keys when the app restarts. Next we use a try with resources block to create a file output stream using the public key path. We create a X509 encoded key passing in the encoded result of the public key. And finally, we use the file output stream to write the encoded key spec to file. I'll copy paste this to do the same for the private key. Change the key spec class and use the getPrivate method on the key pair. We'll want to wrap this code in a try-catch block and collapse the catch clauses. And lastly, return the key pair variable. So now in dev mode, if the public and private keys don't exist, they'll get generated, and next time the app restarts it will read the previously generated keys. But in production mode, when the prod profile is active, if the keys don't exist, an exception will be thrown. With our key utils in place, we can now create the token decoder, which will be used by the resource server to decode the access tokens. Open the web security class and define a JWT decoder bean. I also add the primary annotation because we'll have another JWT decoder for the refresh tokens, and we want the OAuth 2 resource server to use the one for the access tokens. Then return a Nimbus JWT decoder with public key. Inject the key utils class and call the getAccessToken public key method, and finally call the build method. Next we create a JWT encoder to create tokens. Here we create a JWK instance using an RSA key builder, where we pass in the public and private key. Then create a JWK source, and lastly return a new Nimbus JWT encoder. So that's the access token decoder and encoder. The OAuth 2 resource server will automatically pick up the decoder and use it to verify access tokens, and will use the encoder later to issue access tokens. Now we'll create the same beans for the refresh token. And I replace the primary annotation with a qualifier to be able to reference this specific bean later on. And change the code to use the refresh token public key for the decoder, and do the same for the encoder. The OAuth 2 resource server will verify the access tokens, but we also need a way to verify the refresh tokens. For that, we'll create a JWT authentication provider bean and add a qualifier to be safe. Create a new JWT authentication provider, passing in the refresh token decoder. We'll also set the JWT to user converter here and return the provider. Next we can start working on our endpoints. Create a web package and then an auth controller class. Add the REST controller and REST mapping annotations. Define a register post request which takes a sign-up DTO as the request body. We don't have a sign-up DTO, so let's create it. Create a DTO package and a sign-up DTO class. Define a username and password variables and add the lombok getter and setter annotations. Back in the auth controller, import the sign-up DTO. Then we create a user object passing in the username and password. Then we'll want to use the user details manager to persist the user. We don't have a user details manager, so let's create that now. Create a service package and the user manager class. Add the service annotation and implement the user details manager interface. We'll want to inject the user repo and a password encoder, then implement the required methods from the interface. The createUser method takes a user details class, but we know we're passing in a user document, so we can cast a user argument to a user class and overwrite the password value with an encoded version of the password. Lastly, use the repo to persist the user object. I'll also implement the userExistsMethod method and load by username method. Coming back to the auth controller, we persist the user, then create an authentication instance using the username password authentication token. Then we will return the access and refresh tokens. We'll need a token generator for that. In the security package, create a token generator class. Add the component annotation. Then inject the JWT encoder for the access token and refresh token. Note, the JWT encoder for the access token has been marked as primary, so when no qualifier is used, it will be the access token encoder, while for the refresh token encoder, we need to use the qualifier to tell Spring which bean to inject here. First, let's create a method to create an access token. It will take an authentication argument. Then we get the user document using the authentication.getPrincipal method. Then we create a time reference to this point in time. Then we create a JWT claim set, which contains details about the access token to generate. We set the token issuer, the issue that date, the expiration date, which is 5 minutes from now, we set the subject to be the user ID, and then we use the access token encoder to encode the claim set and return the token value. Then I create a similar method for creating a refresh token, except I change the expiration date to be 30 days. You can externalize the expiration values to use environment variables if you wish. We want to return the token values in an object containing both the access token and the refresh token. Let's create a token DTO for that. In the DTO package, create a token DTO class. Add the user ID, access token, and refresh token string variables. And add the getter, setter, all-args constructor, and no-args constructor annotations. Back in the token generator class, add a public create token method which returns a token DTO and takes an authentication object as an argument. For safety, we add a check to ensure the principal object of the authentication object is of a user type, otherwise we'll throw an exception. Then we create an empty token DTO. In the if check, add an implicit cast variable. Set the user ID on the token DTO from the user object and set the access token on the token DTO. Now for the refresh token, we'll do something different. We'll have one endpoint for the token, where a client must apply a refresh token to get a new access token. What we'll do is check the refresh token expiry, and if there are less than 7 days of validity remaining, we'll create a new refresh token and return it to the client. Otherwise, we'll return the exact same refresh token that was passed in. Define a refresh token string. Then we check if the credential is a JWT type and implicitly cast it. Then I create a time reference to now and get the duration between now and the refresh token expiry date. Then I check how many days are in that duration. And if the remaining valid number of days is less than 7, I create a new refresh token. Otherwise, I reuse the refresh token passed in. And if the credential is not a JWT type, then I create a new refresh token. Finally, set the refresh token value on the token DTO and return the token DTO. Back in the OAuth controller, inject the token generator and return a response entity .ok and use the token generator to create a token DTO, passing in the authentication object. Also, we need to define the password encoder. In the main application class, define the bcrypt password encoder bean and add the enable Mongo repos annotation. We'll want to connect the app to a database before we can run it. In the root of the project, create a Docker Compose file and create the MongoDB service, specifying the required environment variables. Next, open the application.yml file and add the Spring Data MongoDB URI property, and we'll externalize the values here. Then open the application dev.yml file to provide the required environment variables in dev mode. Then run docker compose -d to start the database container. Then start the application. And we get an error. So our Spring app doesn't know anything about the different profiles we want to use, so by default it uses the default profile. Open the application.yml file and set the Spring profile active property and set the value to dev. This will enable the dev profile. Now start the application and you shouldn't see any more errors. Now open Postman and create a post request to the register endpoint. Set the body to raw JSON and define the username and password and execute the request. It also helps to use the correct endpoint. Make sure it's API/auth/register. Execute the request and we get back the user ID, access token and refresh token. Now we can work on the login endpoint. Define the login endpoint, which is a post request and accepts a login DTO body. In the DTO package, create a login DTO class. Define the username and password string variables and add the getter and setter annotations from lambok. Alright, so now we need a way to verify if the incoming username and password is valid for a user. For that, we need an authentication provider. Go back to the web security class and define a DAO authentication provider bean. Create a new DAO authentication provider. Next, inject the password encoder and the user details manager. Then set the password encoder and the user details manager on the provider and finally return the provider. So this authentication provider will be used to verify if a username and password combination is valid against the user records in our database. Back in the auth controller, inject the DAO authentication provider and use the DAO authentication provider to authenticate the incoming username and password. If the authentication succeeds, the returned authentication object will contain the user principal, otherwise an error will be thrown. Next, use the token generator to create an access and refresh token and return it. Now in Postman, execute a login request to the login endpoint, and we get back the access and refresh tokens. Next, we create a token endpoint that will be used to acquire new access tokens, and when needed, a new refresh token. Create the post request and we'll reuse the token DTO for the body. The client will need to supply a valid refresh token before a new access token can be issued. Before we issue a new access token, we need to verify the refresh token. For that, we need to inject our JWT authentication provider for the refresh token. Then we use the token authentication provider to authenticate the incoming refresh token that's wrapped in a bearer token authentication token. If the refresh token is valid, it is decoded, then our JWT to user converter is executed, converting the JWT token to a user object. Lastly, we use the token generator passing in the authentication object to return a set of tokens. In Postman, create a new post request to the token endpoint. For the body, use an object with a refresh token property and supply a valid refresh token that you can get from the login request. Execute the request, and we get back an unexpected 401 response code. To better understand what's happening, I turn on debug logging for the Spring Security Framework. Executing the request again, we see that the refresh token is invalid in the logs. I also want to add some logs for the keyutils class, so open it and add the SLF4J annotation, and add a log message for when the keys are loaded from files, together with the actual file paths. And add a log message when the keys are generated, along with the file paths. Start the app, and we can see the keys are loaded from files, but the file paths are incorrect. And also we can see the keys are generated in the root folder. This is not what we want. Delete those keys. Back in the keyutils class, for the @value annotations, we need to use the $ curly braces syntax to read environment variables. So update the 4 variables with the right syntax. Now when we start the app, our log message confirms the keys are generated in the correct place. Now back in Postman, execute the login request to get a refresh token, then execute the token request, and we get back an unexpected response again. Looking at our log messages, the refresh token is still invalid. Looking at the token generator, we are actually using the wrong encoder for issuing refresh tokens, so let's fix that by using the refresh token encoder. Now restart the app, execute the login request again to get a new refresh token, then use the refresh token to execute the token request, and this time we get back a new access token and the same refresh token. We get back the same refresh token because it has more than 7 days left until expiry. If it had less than 7 days left, we get back a new refresh token. Now let's actually put the OAuth 2 resource server in action and create some authenticated endpoints. In the web package, create a user controller. And it would help if I can spell here. Add the usual REST controller and request mapping annotations. Inject the user repo and define a GET request with a variable ID. Add an empty pre-authorize annotation and define the method. We can inject the authenticated principal argument here, and we'll use the IT path variable to look up users based on ID. Next, finish off the authorize logic where we compare the authenticated user ID against the ID path variable. If the values are the same, the request will be permitted, otherwise the request will be denied. This request will simply return a user object, but we don't want to return the user document directly, so we'll create a user DTO to only return a subset of properties. In the DTO package, create a user DTO class. Add the builder and data annotations from Lombok. The builder annotation adds a builder to enable us to build a user DTO object with builder style. Then I define the ID and username string properties, since that is all I want to return to the client. Then I define a convenient static method to create a user DTO object from a user document object. and I use the builder to create the user DTO object. Back in the user controller, we use the repo to look up the user by ID, and then use the user DTO convenience method to convert the user document to a user DTO. The find by ID method returns an optional value, so we need to decide what to do when there is no value. I chose to throw an exception in that case. Now start the app. In Postman, execute the login request to get an access token. Create a new GET request, and in the Authorization tab for the type, choose bearer token and paste the access token value. Update the URL to point to the user endpoint and specify our user ID. Execute the request and we get back a user DTO. Now let's say we want to access another user's details by changing the user ID in the URL. When executing the request, we get back a 403 status code forbidden. So that's our pre-authorized check at work. And that's our backend essentially done. Now for the refresh token, we're only checking if it's a valid refresh token. There are no other checks, such as checking if it's revoked, which we implemented in the previous video. To have revoking capabilities, we need to keep track of issued tokens and have a revoked flag. To get details about the refresh token, in the token request you can get access to the JWT token itself by calling the get credentials on the authentication object. Then you can perform additional checks against the DB if you wish. And that's it for this video. Thanks for watching and see you in the next one.